Hey all, and welcome to Chapter 5. So Chapter 5 is about geometry, it's about shapes. And so we're going to start off by doing some practice in 5.1 and 5.2. So get yourself ready for notes, and we're going to talk about some of the terms that we're going to be using when we talk about geometry. So some of these I expect that you already know, some of them might be new, but here's a nice list of the ones that I expect you to all have come in being somewhat familiar with. Acute angle, right? This is an angle that's less than 90 degrees that looks like this. Obtuse angle is an angle that's greater than 90 degrees. And it's going to look like that. And a right angle is perfectly perpendicular. You show it with the box like this, and like what we see in this picture here at E. And this is exactly 90 degrees. Perpendicular describes two things that meet at a right angle. So E is a right angle here, and the things that are perpendicular are the segments AB and CD. Now a line has the arrows on both ends because it goes on forever. As I just said, segment would have endpoints like this, and a ray is in the middle where it's got an endpoint on one side and goes on forever in the other direction. So those are ones I expect you to come in knowing. Now here's some new ones maybe. For some of you might be already familiar. Complementary angles. These are two angles. So two angles that add up to 90 degrees. So if I'm asking for, in number 1A, a set of complementary angles, I'm going to look at this picture. I'm looking for two angles that add up to 90 degrees. So I'm going to look at these two here. And in this case, when I label angles, I say you draw the angle symbol. And then the way you label it is, in this case, I'm going to call this angle here, so C to E to F, this larger but still acute angle, I'm going to call it CEF. So you write it in the way that it looks, where we start at C, we go to E, that's where we turn, and then that's F there. This place that we turn, in this case here, is called the vertex. It's right in the middle, and you write it in order. The only other way to label this angle would be FEC, which still has the vertex in the middle. The complement of FEC or CEF is FEA. So that's a smaller one here, goes from F, the vertex at E, out to A. The next terms are supplementary angles, and these are two angles that add up to 180 degrees. That add up to 180 degrees. So 180 degrees is a straight line, right? It's two 90-degree angles together. So we usually just think of that as one straight line versus 90 degrees as we illustrated up there. So if I'm looking for supplements, I can look at the other side of the graph, and we could say this angle here is supplementary to the other side, and then here's our straight line, our 180 degrees, right, like that. So the way I would write that, I'm just going to zoom out a little bit to give us enough space. If I want to write that, that's CEB. So angle CEB in that top part, and then angle B to E to D. Those are supplementary angles. Now our last term here are vertical angles. These are two angles that share a vertex. So if you look at the picture that we did for 1A, the vertex is the turning point of the angle. So if I look at this picture here, every angle has a vertical angle in this picture. So if I just pick one, like I'm going to say, here's this one hasn't been colored yet. That's one angle. The vertical angle is the one directly across from it. So it doesn't share anything else, right? This side and this side aren't shared. This one here, but they do both have this same vertex right in the middle. So those would be a set of vertical angles. And those would be called in below A, E, D. So that's this one here, A to E to D. And then the upper one is, again, C, E, B from part B. All right, we're going to talk about a little bit more vocabulary. And we're going to talk about parallel lines. Again, this is one that I would expect you to know. These are lines that never cross, or could be a plane, could be a flat surface that never crosses. And the way that we show that two things are parallel, if we look at this picture over here, is if I want to show in a drawing that they're parallel, I'm going to draw a little V on both of them pointing the same direction. So this just shows that they're parallel, that they never cross. Now, new word for maybe some of you is transversal. And this is a line or a segment or a ray, right? We talked about the difference of those two that cross the parallel lines. So if I look at the picture over here, this one that's not parallel, this is our transversal. And then we have our two parallel lines that are going horizontally in this case. Now, congruent, this just means that they are the same size and the same shape. Sometimes this is called having equal measure or equal measurements. And the way that we show it, the symbol that we use is like an equal sign, but then it's got a squiggle over it. And it just means they're not just numerically equal. Every angle, every side length, all of the shape is equal. So that's what congruent means. Now, if we're looking at parallel lines cut by a transversal, they have this really important characteristic that it creates congruent angles. So in this case, it's number 2, identify all angles that are congruent to angle 3. So here's angle 3 here. Now, if we look at our drawing, obviously angle 3 and angle 1 are not the same. But every acute angle like this that's created by this transversal on parallel lines are going to be congruent. So 3 is going to be congruent to 2. If you look down at the second line, you're looking at the same acute angle. 7 is also acute, as is 6. So everything that's congruent to 3 would be the angle at 2, the angle 6, the angle 7. Also, the obtuse ones are all congruent. So 1 is congruent to 4, 5 is congruent to 8. So we would have a separate set of obtuse angles. And that's what's going to be helpful in answering our last question here, 3. So this says, if M angle 5, what that means is the measure, that's what that M stands for, of angle 5. So as we said, measure up here is talking about its size, just in our definition of congruent. So you have to use some context. That could mean the length of something. That could mean whatever the angle measure is in degrees. It could be width, it could be height, anything that we measure, etc. So what we're looking here is that we say, oh, if our obtuse angle is 110 degrees, find the measure of angle 2. So if you look here, angle 2 is one of our acute ones. So this is the acute size. And since this is 110, that means that it is 110 is greater than 90 degrees. this is our obtuse angle. And since they are on lines, so 5 and 6, 7 and 8 are all on a straight line here, that means that these sets are supplementary. Meaning that, again, they add up to 180 degrees. So 110 plus whatever angle 2 is equal to 180. We can subtract away on both sides, and we find that the measure of angle 2 is equal to 70 degrees. Let me know if you have any questions about any of these vocabulary words, and I recommend you keep them easy to access